Conventional supply chain for spare parts can be a nightmare. Between long lead times, overstocking, and obsolescence, industrials have huge physical stocks of spare parts sitting on shelves, and costing them hundreds of millions. For decades, and still today, supply chain managers have built complex logistics systems to balance stocks and the risks of downtime. Thanks to the combination of digital inventory and mature 3D printing technologies, these parts can be available on demand. Here comes the distributed manufacturing using 3D printing. This evolution is leading to a new optimum, more respectful of the planet and finances. A simplified and decarbonized supply chain. But this requires to create a digital inventory of your parts. For each part, a digital passport will be built, encompassing all specifications, drawings, and production plans of the part. Creating these digital passports for a digital inventory is a complex journey for those who don't have the know-how. Spare Parts 3D mission is to facilitate your journey. In our product tutorial, we will show you how to use DigiPART to browse through your inventory of spare parts, how to analyze them in details, how to prioritize your digitization plans, and finally, how to build your digital inventory. With DigiPART, you will be able to generate value while digitizing and decarbonizing your spare parts supply chain.
Welcome to this tutorial. Today, I'm going to introduce you to the DigiPART software solution. Welcome to DigiPART. First of all, let's connect to your account. Enter your username or email and your password. Your homepage displays your organization projects. If you are looking for a specific project, simply type its name in the search bar. You can access your existing projects or create a new one. The left side menu gives you access to the different phases of your 3D printing journey. All DigiPART users are trained by our Spare Part 3D team until they can operate autonomously. Let's start a project together. This is the first phase of your 3D printing journey. Parts identification. Which of your spare parts are printable with additive manufacturing? And which of those are financially competitive compared to conventional supply chain? Let's get those results step by step. Go on to the DigiPART homepage and click on Create Project. Type in your project name and select your data dimensions units. Then browse or drag and drop your bill of materials, that is your spare parts data. In the section below, you can add any additional files associated with your spare parts. DigiPART will automatically recognize the part number and add the file directly to the corresponding part section. These files can be 2D or 3D drawings, technical data sheets, pictures, and so on. You don't have the parts drawings? DigiPART is an AI-powered software and is able to analyze your spare parts data, even without 3D models. To prepare your data for DigiPART, click on Download Import Template. Then, click on the Import Template Guide. Read this guide to prepare your import data file. This is the Download Import Template. It is crucial that you keep the predefined column names. DigiPART will recognize and interpret data for columns precisely matching these names. You can also add new columns if you want to keep record of any additional information. This is how the import file looks like after being filled. Always refer to the Import Template Guide. In this example, there is missing information in some columns. This is quite natural, because in your ERP, you don't necessarily register all the technical information. Spare Parts 3D is able to complete partial data to perform a better assessment using DigiPART. The process starts by decoding and enriching your data. We are capable of using long descriptions, like this typical extraction from a customer's ERP. We read the data and extract the information. For example, here is the parts material. And here, its dimensions. The algorithms are capable of extracting and structuring the information. Powered by machine learning and an extended database of spare parts, the algorithms can also fill in the blanks on missing pieces of information. Once the data is ready, you can get to the next step of analysis using DigiPART. In order to adapt to the situation of each organization, different tools are used to structure, decode, and enrich data. This data can come from a wide variety of sources. Let me introduce you to two key modules of DigiPART technology, the computer vision and the clustering tools. The first module is able to read 2D drawings. It automatically extracts key data using a combination of computer vision and deep learning technologies. With the new data, it can complete your partial spare parts data. This computer vision feature can also generate a 3D file automatically from your 2D file. Let's pick a 2D drawing, like this one, and upload it here to be read by the computer vision. Simply drop the file and wait until it's processed. Multiple 2D files can be uploaded together. DigiPART will inform you once the files have been processed. You see the list of files uploaded here. The results are now ready. On the left, you see a preview of the 2D drawing. On the right, you can see the information that has been extracted from it, such as dimensions, volume, and material details. They will be used in DigiPART to enrich your partial data. If you scroll down, you can see the generated mesh. This is the result of the automated 3D model reconstruction. Today, DigiPART provides an approximation of the part's final shape. Developments are ongoing so that DigiPART is able to reconstruct the exact part shape, with its tolerance, in the near future. The associated 3D file can be downloaded here and used for your Part AM technical analysis. Let's get back to your original workflow. You just uploaded your import file. Now, your spare parts data is in the DigiPART database. At that stage, no analysis is run yet, and you may still have partial data. To assess the technical feasibility of your parts for additive manufacturing, the parts specifications need to be defined. To do so, all the parts are organized in standardized part categories within DigiPART. Part categorization is the backbone of the analysis. It is based on natural language processing algorithms. It helps to automatically generate, on a large scale, the part's functional specifications in a minimum amount of time. These specifications are, for instance, the required corrosion resistance, temperature of use, or the surface hardness. How does DigiPART efficiently assign part categories to hundreds of thousands of parts? Let me introduce you to the DigiPART clustering tool. Clustering simplifies the categorization parts based on the parts' information similarities using graph theory science. The process of clustering is divided into 4 stages: stop words, create graph, create clusters, and clusters. To start clustering your part, you need to tell DigiPART on which criteria you want to run the computing. The most standard criteria would be part name. The first step of the clustering is to list the stop words, meaning all the words which you don't want parts to be grouped on, such as the manufacturer's name. DigiPART sorts the words in 3 columns. The common words are ones that can be found in a dictionary. The near common words are the misspelt words. And the suggested words are the ones that DigiPART recommends you to set as stop words. Simply select and drag the words to the final stop word list on the right. Once you are satisfied, save the selection. You are now redirected to the second step of clustering, create graph. This section is to define an additional parameter to the clustering process. You can adjust the sensitivity of the grouping process to get smaller or wider groups of parts. Click on Create Graph. DigiPART is now mapping your spare parts data. Once the mapping is done, click on Clusterize. DigiPART is grouping parts into clusters. You are now in the Clusters section. Here is the list of all clusters identified by DigiPART. For each cluster, you can see the number of grouped parts and the word cloud, which are the 3 most prevalent keywords. This cluster has impeller as first occurrence in the word cloud, and it contains 14 parts. Let's have a look at it. You will use this section to define the part category. To do so, you have access to 3 tools. The first one is the word cloud. These are the words that are shared the most between the grouped parts. The part category detection on the right shows you if any of the parts have already an associated part category from your import data file. The third one, on the top right corner, is the centroids recognition. It shows you all the part names that have the highest number of connections and are therefore most likely to be at the core of the cluster. These tools are all here to facilitate your decision-making when allocating the part category. You can choose to use either of them at your convenience. If you want to review the graph on which the whole clustering is based, scroll down and click on Load Cluster Graph. You can see here the different etymological connections between the parts. Now that you know all the clustering tools, let's associate a part category to the parts of this cluster. Each part category is linked to an equipment. These parts are from pumps, and based on your knowledge, you know these are centrifugal pumps. You can either scroll and search like this or type the name of the part directly to see if you can find it. Besides, you can always create a new part category. However, we recommend to allocate existing part categories insofar as possible. DigiPART will therefore be able to compute specifications. It uses an expert system, not only based on your parts data, but on all the existing ones in its database for this part category. You will then get the best results. Select the category that is the most relevant to your case. After associating the clusters with their part categories, you can always edit them. Thanks to the clustering tool and the part categorization, your data enriching can now be finalized. The functional specifications will automatically be allocated, and the technical and financial analysis will be computed by DigiPART for all your spare parts. Let's have a look at the results of the analysis. This is the project dashboard. An executive summary of the analysis run for this specific project. On the left side, you see the part summary card. With the name of your project, the number of parts analyzed, and the number of high-priority parts. This value corresponds to the green boxes here. On this right side, you see the recommendation matrix. This is the most essential element of DigiPART Identify. The matrix displays the output of the analysis, run on all the parts of the project. On the horizontal axis, you see the results of the technical printability analysis. On the vertical axis, the results of the business attractivity analysis. The matrix contains 4 main pieces of information. The boxes in green are the parts that are both highly printable and highly economically attractive. In yellow, the parts for which both technical and economical scores are lower and that you could investigate in the future. In gray, the parts with not enough information for the software to provide an analysis. However, data can be updated at any point in the future to reassess the potential of those parts. And finally, in red, DigiPART displays the parts with lowest technical and economical scores. The results of the business analysis correspond to the supply chain savings that could be generated using AM. This is compared to conventional supply chain costs using conventional manufacturing methods and materials. You can refine your expectation level using the threshold sliders. T1 is for highly attractive parts. T2 is for moderately attractive parts. You can slide the cursors or type the threshold values. The results of the business attractivity also depends on the business case. You can review the matrix results, selecting the most appropriate business case. The business cases can be customized to adjust with your cost-controlling calculation methods. Now that DigiPART has provided you with its recommendation, you can have a closer look at the most relevant parts. You have now selected your business case and defined your thresholds. Accordingly, you can see here that there are 4 parts that are highly printable and highly attractive. You might want to focus on those ones first. Let's click on these parts and access the part list. You are now in the part list section. From there, you see the 4 previous parts: highly attractive and highly printable. To advise your project team on which parts need to be reviewed, you can first select these parts. Then, tag them by clicking on the button Tag Selected Parts. From there, search your desired tag, like Priority 1. You can also add a new one. Type the name of your tag. Then, click on Add, and customize it. When you are done, click on Update Tag. Let's add a tag, Need Engineering Review, to our 4 parts, as a call for action. Your first assessment is now completed. Let's now take the point of view of an engineer. From the home page, you can directly enter the project part list. Now, you can find the tags that require your attention. Let's have a look at the impeller. You are now in the impeller part view section. All the data uploaded for this part can be viewed and updated in the upper sections here. This first subsection is the executive summary. This is where you can have a snapshot view of the technical data and financial data of the part. You can now go on to the input data subsection, where the information is stored for traceability purposes. Here you find all the information that has been uploaded by your team. In the center, you have all the information categories that have an impact on financial and technical analysis. On the right side, these are the added ones that might have an importance for your organization, but which are not taken into account for the analysis. If you scroll down, this is the section where you can add and store any file for this part. It might be drawings, 3D file, data sheet, pictures, etc. You can update, remove, or add any data in this entire section. Now, let's proceed to the next step. Go on to the part information subsection. Here you can see the list of specifications for the impeller. They have been fetched by DigiPART during the data uploading process. These specifications represent the DNA, or the blueprint of the part. They are used to run one of the key modules of DigiPART technology, the Additive Manufacturing Transfer, or shortly, AMTF. This module is the one that analyzes the part technical feasibility for additive manufacturing. Each specification is composed of a property and its acceptance range of values. The properties are automatically defined from the part category and the environment, while the range of values is determined from the conventional material. You can change the part category and the conventional material, and also remove or add environment descriptions. For the example of the impeller here, let's remove the oil environment and add the seawater one. To validate and compute these modifications, you need to click on Fetch Specifications. You can see here that the properties have been updated with the seawater environment. Your part blueprint is set. Remember, these specifications are the ones from the conventional material. To compute these specifications and get the part additive manufacturing recommendations, click on Run AM Transfer. Now, DigiPART is comparing the part specifications to the 3000 additive manufacturing solutions from our database. Each solution is composed of one material and one AM technology. The AM transfer is now completed. Let's have a look at the results. You are now in the Technology Transfer subsection. Based on the input conventional material, here is the list of all the AM feasible solutions for the impeller. These solutions are listed and ranked according to their specification score. Each solution is composed of an AM technology and a material based on existing knowledge for a specific material. An estimation of a unit part printing cost is also presented. New solutions are constantly updated by our engineers. It means that parts which are not printable today might be printable in 6 or 12 months down the road. It also means that you can use DigiPART to reassess your entire part inventory printability at any time to grow your digital inventory. DigiPART gives a recommendation for the solution with the highest specification score and displays it in the main box on top. You can review the details of the specification assessment here. When it's green, the value is in the range of the specification. In red, the value is either lower or above the predefined range and subject to an engineer review to be further qualified. Solutions are rated as high, medium, or low, depending on the specification match. More than 80% match is considered as high printability, and below 50% as low printability. If you click on the arrow on the left, you see the different solutions resulting from similar grades of one material. They can also be reviewed and compared. At this point, you have validated that the input data and part specifications are correct. You are also interested in one or more AM solutions. Let's then move on to the next step. Go on the executive summary. Remove your call for action tag. Let's add a tag, Engineering OK, and Need 3D Drawing. The 3D drawing is needed to validate the AM solution. There are 3 cases at this stage. In the first case, you only have the physical parts. Therefore, you'll need to have that part scanned and the 3D file prepared. It can be done by your engineering team or a service provider. In the second case, you have the 2D plan of the part. In this situation, you will soon be able to use the DigiPART computer vision. As shown earlier, this feature will reconstruct a 3D file from your 2D drawing. In the third, and easiest case, you already have or can get the 3D file from a third party. Once you have the 3D file, go to the Input Data subsection. You can add any type of file at the bottom of the page. Click on the plus sign. Choose your files type and upload them here. Let's add a picture of the part. This is where you can store and list any files for the part reference. Let's also add the 3D file on the top left section shortcut. Pay attention to the data input before importation. And after importation, you see that the data has directly been updated. The data in the 3D file always takes priority over the initial input data. Go on to the executive summary. Remove Need 3D Drawing. And add a tag, Need AM Review. Now that the 3D file has been uploaded, you can go back to the Technology Transfer subsection. DigiPART uses the 3D file to perform a printability check. The results are displayed in this column. Let's select multiple solutions to compare their printability. Click on Compare Solutions. You are now redirected to the AM Compare subsection. Here you can compare the 3D analysis. You see for these examples that the minimum wall thickness requires your attention. You can quickly check where the risky areas are. You can also quickly review the part cost breakdown. And at the bottom of the page, you can compare the technical analysis. Based on your evaluation, you want to go on with the first solution. Go back to the Technology Transfer subsection and select the desired solution. Go on the Executive Summary. Remove a Need AM Review. And add a tag, AM Solution Selected. At any time, you can also review the results of your different business cases for this specific part. In case of missing information, or if the value is negative, you see 0, displayed in red. Of the 9 business cases defined for this project, you see 3 opportunities to choose this part for AM. On the top of the list is displayed the best business case, which corresponds to the 3 years cash out reduction here. Below, the supply and inventory section provides your part financial input data. They can be updated either here or in the input data subsection. Now that you've been properly introduced to the platform, let's dig deeper into the deploy solution of the software. The DigiPART Deploy module is a business intelligence tool that enables you to understand, in depth, your data and take action over it. It is, for instance, used to help prioritize the parts that shall be digitized first, or to make a make or buy decision on your supply options. Let's get out of the part view and go back to your project dashboard. Have a closer look at the down left section. This is the Filter Set tool. It enables you to refine your data based on your requirements and narrow down the search to get other parts you want to focus on. Let's create a filter set together. Click on Create New Filter Set. Give it a name and description. To add a filter block, click on the plus icon. You can choose a field to filter the data. It can be directly linked with a previous filter set, the part attractivity, or one of the spare part fields. Let's filter based on the price of the conventional part. Then, you can choose an operator and the associated value. The results will be displayed in 2 ways. First way is the graphical view that you can customize. Second way is the list view, which displays the total count and filtered count. At the bottom, you can see the final results of the filter as percentage and parts count. The refined data of this filter set is also directly reflected on the AM matrix. You can add multiple filter blocks to get additional filter layers. Like conventional material, for example. The value type of the selected field sets the operators displayed. You can enable and disable filter blocks at your convenience here. If you select one of the matrix cell results, you get the list of the filtered parts according to this specific filter set. You can also deactivate filter sets here and reactivate them by clicking on the ones you want. Let's now have a look at the analytics section here. Here you find the pivot tables. They enable you to create reports with the refined data and requirements you need based on the entire project dataset. Let's create a pivot table. Name it and add a description. You can refine the data using the tags or filter sets. Find the field for which you want to create the report and enter the number of parts you want to be displayed. Let's generate a report for this project with the top 5 part categories and the top 4 conventional materials ranked by price. You can click on Add Count column. Let's also add more columns like Best Business Case, Weight, and Average Yearly Demand. Click on Create and you can directly get a view of the report. This report can also be copied as CSV. Thanks to Deploy, you can now build your digitization plan focusing first on the parts that can generate most savings, such as the wear rings and impellers in this example. Identification and deployment are now well underway. You might want to move on to the next phase of your digital inventory journey. It's time to create your digital catalog in DigiPART. This catalog will be composed of all your parts' digital passports. Let's go to the impeller part section to create a digital passport. Go to the Technology Transfer subsection. You find the solution you selected previously. Click on the dark blue box here to generate a digital passport for the impeller based on this specific solution. Give it a name and create it. Once it's set, you are redirected to the Digital Passport subsection. A digital passport combines all the essential information for AM. There are the 3D file, the specifications, the material, the technology, and any additional information like manufacturing plan, inspection document, certification report, and so on. You can also quickly access the AM material specifications and the process specifications. Once you approve a digital passport, it can no longer be changed and its components are cast in stone. Let's approve this one. You can have as many digital passports as there are existing solutions. Different passports lead to different AM technologies or materials. This allows you to further extend the AM options for a single part within your printing network. To access your digital inventory, click on Catalog on the left side menu. All digital passports are compiled and stored here. They form your organization's bespoke digital inventory. You find here information such as the name of the passport, the associated part number, and the part name. You can filter and find any list of digital passports using this refining tool. You can perform 2 specific actions from the catalog. First, qualification print option is intended for passports that have yet to be qualified. The second one, get a quote option, is displayed for the approved digital passport. In both cases, you can connect to your network of suppliers and request a quotation. Let's request a quote for this part. You can make all the modifications that are suitable for the quotation. Project name, quantity, additional files, or comments for the supplier. The quotation phase can be structured any way you like. We can either onboard your own qualified 3D printing suppliers, internal or external, or connect you to platforms such as Siemens AM Network. Once they are in your environment, they will be able to receive your requests and orders directly. Send your quotation, place your order, and trace all your parts requests and orders in the DigiPART print module.
DigiPART is a one-of-a-kind end-to-end software that is accurate, scalable, completely transparent, and adaptive to your organization's technical and economical environment. With DigiPART, distributed manufacturing will become a reality. Your company will be able to identify and digitalize parts at scale. You will be able to generate savings and a reduced carbon footprint for your spare parts supply chain.